Hello everyone, my name is Jiaming Xing, and let me show you guys my homework 1. So there is the first question. For any arbitrary event ABC with the probability of C is greater than 0, so prove or disprove that when C happens, the probability of A union B is greater than or equal to 1 minus the probability of A union B union C divided the probability of C. So let's start. The probability of A union B union C equals to the probability of A union B plus probability of C minus the probability A minus A union B intersects C. And when C happens, the probability of A union B equals to the probability A union B intersects C divided by the probability of C. And let's multiply the probability of C in the both sides of the identity. So after that, the left side equals to the probability of A union B intersects C, and the right side equals to the probability of A union B intersects C minus the probability of A union B. And then because that the probability of A union B is greater than or equal to 0, so the left side is greater than or equal to right side. So this question is proved. Here is the next question. Given that the probability of A is greater than 0, less than 1, so as the probability of B, proves that when B happens, the probability of A plus B bar happens, the probability of A bar equals to 1 if A, B are independent. So if A and B are independent, and A bar and B bar are independent too, and when B happens, the probability of A equals to the probability of A intersect B divided the probability B equals to the probability A multiple the probability of B divided the probability of B equals to the probability of A. And when B bar happens, the probability of A bar equals to the probability A bar intersects B bar divided the probability of B bar equals to the probability B bar multiple the probability A bar divides the probability B bar then equals to the probability A bar. And the probability A and plus the probability A bar equals to when B happens, the probability of A plus when B bar happens, the probability A bar equals to 1. So it is proved. Then if when B happens, the probability of A plus when B bar happens, the probability of A bar equals 1. We want to prove it is independent of A and B. So it equals to the probability of A intersect B divides the probability of B plus the probability of A bar intersect B bar divides the probability of B bar equals 1. And the probability of A bar intersect B bar equals to 1 minus the probability of A union B equals to 1 minus the probability of A minus the probability of B and plus the probability of A intersect B. So this equals to the probability of A intersect B divides the probability B plus 1 minus the probability A minus the probability B plus the probability A intersect B divides 1 to 1 minus the probability B equals A. So we can divide we can multiple the probability b multiple 1 minus the probability b in both sides. So we can get this identity, and maybe we get the final identity is the probability of A intersect B equals to the probability A multiple the probability B. So A and B are independent. So this question is also proved. Thank you very much.